This is the next edition of BobCAD's webinar series. Today's topic is textures for 3D milling. As you know, my name is DePoalo. I'm the voice of the BobCAD After Dark video series. You can find me at DePoalo on Instagram or hashtag BobCAD After Dark. You can also find me on YouTube just by searching BobCAD. I'm pretty sure I'll come up. Okay. The goal of today's webinar is to show you a variety of techniques you can use to create textures and patterns on your 3D parts. We're going to talk about our standard toolpaths for textures, things like planar, radial, and spiral. We're going to talk about how you can use the angle of the toolpath to help with textures. We'll talk about, your step over value and the effect that that has on your parts as well for your textures. We're also going to look at how you can use allowance as well in order to put textures kind of like the spiral we see here. Now the big benefit of using the standard toolpaths for textures are they're easy to set up and change using toolpath settings you're already familiar with. Okay, so you can lay down a planar, a spiral, a radial, and be able to just make some adjustments to the toolpath settings in order to get these patterns into the part. Now the other thing we're going to look at is project curves and 3-axis wireframe. Okay, project curves in this example is a CAD feature, so we're going to use project curves to project our geometry down on surfaces, and then we're going to use our 3-axis wireframe toolpath in order to generate our toolpath and G-code. Now, one of the benefits of this is instead of the standard toolpaths where you have certain patterns, now you can use any pattern that you define by the geometry that you're using. Okay, you also have a step down for roughing, so you can take multiple passes to get down, so that way if you're, you're not too aggressive, or you have control over how aggressive you can be or not depending on the material. And again, we're going to talk about using allowance and how you can use allowance in order to affect the finishes that we're going to have here for these patterns. Now the benefit of using project curves and 3-axis wireframe is you're using your 2D drawing patterns on your 3D surfaces. So you can draw out a pattern in wireframe, apply it to your surface, and turn it to toolpath. Really cool feature to use. All right, the next thing we're going to talk about is the Mill Pro Project Curves toolpath. Okay, so there's some differences between the 3-axis wireframe and the Project Curves toolpath. One thing is tool compensation. We'll talk about that a little bit and the effect that it has. The other thing we're going to look at here is negative stock, how you're going to use negative stock. Actually, I mean negative allowance there, so I apologize. Negative allowance. And then the other thing we're going to talk about is lead in and lead out options. Okay. Now the benefit of the Mill Pro Project Curves toolpath is you have more control over how the tool is applied to the surface, and you also get more consistent results. So we'll look at some examples there. The next thing we're going to talk about is the BobART in Textures. So how you can use BobART in Textures. BobART is an add-on. It's one of our most popular add-ons, and there's a lot of things that you can do with it. Textures is one of them. We're going to talk about using images for patterns, like in this example. We're also going to talk about the emboss texture feature. How we have a feature specifically for creating textures. It's called emboss texture. So we'll go into that a little bit. And then we're also talking about the smoothing option. So after you apply a texture, how you can smooth it out on your surfaces. Now, the big benefit of the BobART for textures is you can create complex textures easily using images. So instead of having to create wireframe or projection, all these other things, you can just use an image, and that image will create that texture. Now, there is a special offer available for everybody that attends today's webinar. The only way to get this offer is to call in off of this phone number, 877-333-4903. We're doing something really special today, so don't forget at the end of the webinar, make sure to call in off of this number to find out about the deal. They wouldn't let me in on exactly what it is, but I know it's something big today, so definitely take advantage of that. And as you know, fewer steps, better cuts equals more profits, and that's what we're talking about here at BobCAD-CAM. All right, so give me a second here to just get my screen set up, and we're going to go ahead and dive right in. Tim, I know you had a question about the how you get sound and video. You're going to have to look through the GoToMeeting panel there. You can use your mic and speakers and listen through your headset, or you can call in the conference line, whatever is going to work best for you. And I apologize if you're having any difficulty. All right, it looks like you're all set. Okay, so let's see what we have here. Now, so what I'm going to do is I'm going to start off with this file here. And really, what we're talking about, or why we're holding this webinar today, or what the topic is really about, is for people who have ever wanted to punch up their designs. You know, add some tool marks or textures to change either the look or the feel of your parts. In today's webinar, we're going to talk about 4 different techniques you can use to create textures and patterns on your 3D parts. So to get started, we're going to go right into the standard Toolpaths. Okay, so here I have the model set up. This is the model one of the models I use for the 3D boot camp. We have, if we look at it from a top view, you can see there's a taper on the wall. If we look at it from a front view, you can see that there's some curvature here. If we look at it from a side view, you can see there's some curvature as well. Okay, so this is genuinely, when we're talking about textures and patterns, I mean, there's a lot of different parts that you can use these types of things on, but usually, you know, curved surfaces is what we're talking about, because if it was flat, then you could just use engraving or something like that. All right, so the first one we're going to look at is the planar toolpath. So everybody's on the same page. I already have the job set up here. I have my stock selected as the part model. I have my 0 set to the bottom of the part. Doesn't really matter. I have some material chosen. We're ready to start loading in our toolpaths. Now, the first toolpath we're going to look at is going to be the planar toolpath. Okay, so I'm going to go ahead and select my model here. I'm going to run over to my strategy. I'm just going to choose planar. Okay, we're going to use a ball mill here. The pattern, we're going to put this on a 45. Okay, the tolerance, I'm going to loosen up just a little bit. And I'm just going to compute the toolpath. Okay, so this is a standard planar type toolpath. It's moving back and forth across the model. You know, like it would normally work. Now, here's the thing. This pattern actually would do just fine, but if we go ahead and let's go ahead and simulate this. Okay, so we're going to launch simulation here. So we have our stock geometry, and what we've done is we've already machined the part to finish, and then now we're trying to put in these textures or these patterns. Okay, so if we run this planar across the model, you're going to notice that it's barely kissing the top of the surface. Okay, so when you're using your standard toolpaths for textures, you need to make some adjustments, and one of the adjustment that you want to make is you want to have it cut into the surface. Or that's one way you can do it, is to have it cut into the surface, and that's really where we start talking about our allowance or our negative allowance. Okay, so what we want to do is, if we go back into the feature and then we go to our parameters, you can see we have an allowance number, and you can, usually we're leaving stock. We're trying to stay away from the surface, so we're leaving stock. In this example, what we're going to use is a negative allowance. Okay, and what that's doing is that's going to drop the toolpath down into the part model. Okay, so this is one of the ways in which you're going to be able to put textures on surfaces, is using the standard toolpaths and just applying a negative allowance to cut into those surfaces. Okay, the other thing I want to do here is I want to you know, space out. When I look at this, I want to look at my step over. I want to increase my step over. Normally we're trying to get the step over really close together. That way we get a nice finish. In this case, we want to leave the tool marks. So in this example, we use negative stock. We spaced out our step over a little bit, or I'm sorry, negative allowance, and we use just a planar toolpath. And this concept we're going to be able to use with our other standard toolpaths to create some really interesting looks. Okay, so we're going to run this through the simulation again, and now we're able to see the toolpath is moving back and forth across the model. And when it does that, you can see we're cutting into the model, so we're getting this textured pattern, okay? Now, generally, a really common strategy is just to do two 45-degree paths intersecting with each other so you get a crisscross, okay? So let's look at how we would do that. Again, it's really simple to do. What we're going to do is we're going to edit our feature, okay? So we're going to edit our feature. We're going to go to our machining strategy, and we're going to just add another planer in here, okay? So now we have two planers. The second planer, we're going to put at a -45, okay? And everything else, we're going to leave the same. What do we have this as? 1/4 inch, okay? Now, one of the things, you know, I went in here and I typed these in, but one of the things you can do is if you go to the parameters tab, if you want this planer and this planer to have the same parameters, you just click apply to all operations and it will update that for you, okay? So we're going to go ahead and recompute this, and now you're going to see we get a crisscross pattern across the part model. When we run this through the simulation, you're going to see a nice crisscross pattern, and then what you can do is you can adjust how deep you want it to cut in by using your negative allowance, and you can adjust how high you want the ridges to be by using your step over, okay? So this is, again, one of the more popular ways to do this is just to use a crisscross pattern here, and you can see we get nice tool marks cutting into the part. Now, some of you may be talking about, you know, the edge of the part and how that looks. You can start applying boundaries. You can do a profile cut. That would be another way around that top edge in order to clean that up a little bit. In this case, we're going to just use a boundary. Let's go ahead and select our top surface here. We'll recompute the toolpath, and what you're going to see is now the toolpath is moved in. Okay. Another thing that you're going to notice is the toolpath is linking, the way that it links from end to end. Sometimes I'll choose to cut these in single directions in order to get a little different a result. So that's the first one that we were talking about, using planer on a 45. Then we use planer again on a -45. That gives us our crisscross pattern. We're using negative allowance in order to cut deeper into the part. We're going to use our step over in order to control the width of the pattern that we're creating. Okay, so hopefully that makes sense to everybody, as I'm sure it does. If there's any questions about that at this time, just go ahead and raise your hand or write a question in the question box. Okay. So this one's planer. That's pretty cool. This is really common. A lot of people probably think of planer. The next one that we're going to look at here is going to be, let's say spiral. Okay. Now, spiral as a toolpath is really best for parts that are more circular in nature. But again, you can create some really interesting patterns using the toolpath. If you can hear me, go ahead and raise your hand. Let me make sure the audio is working. Eric's saying that I'm muted. Okay, Eric, I'm not muted. It looks like your audio may be muted. So if you look at the control panel, there'll be some options for sound that you can work through. Okay, thank you guys. All right, so we got our spiral. We're using our tool. We're going to go to our patterns. Same concept. We have our step over amount. We would use our negative allowance, and then we're going to hit compute. All right, so what this does is it puts a spiral on the part, and again, the shading is just S on your keyboard, okay? So the spiral in itself is okay, but if we want to elongate it or change it, we have some options for you. Okay, so what you would do is edit this feature, and we'll go to parameters. And within parameters, if you've ever used spiral before, you're probably like, well, why does it have an outside height and a width? And the reason why it has this is you can adjust where the spiral is created. Okay, so in our example, we're going to say it's a height of 2. We're going to say it's a width of 6. We're going to bump up our step over a little bit. We're going to recompute our toolpath, and now you can see we can create this spiral toolpath spiraling out on this surface. So again, another way to create a pattern that you could put on a curved surface to really make your part stand out. They're really easy to set up. They don't take much time at all. Hold on a second. Let me close this out. Turn this one off. Run simulation here. All right, and here we can see our spiral routine, spiraling out. Now again, this is where you really do have to pay attention to the step over amount, because the step over amount is going to determine the cusp area. So, you want to increase or decrease that number to get the result that you're after. Okay, so that was just a little bit about spiral. We'll blank that one out. We'll turn that one off. We'll go on to the next one. So this one we're going to load in is radial. Radial, again, is another very popular option. So we'll go to radial. So instead of spiraling, this one radiates in and out. We're going to go, let's do something like this, something like that, and we're going to compute this. Okay, so here you can see we're getting a toolpath that's going to work from the inside, and then it's going to work its way out. Now, one of the things that you're going to notice here is this linking, these linking parameters, and because you have a negative allowance, a lot of times you're going to see these are going to drag along that surface, and that may or may not be the result that you're after. Okay, so if you don't want it to drag along that surface, you can go to a zig pattern and then recompute that, and then now you can see it lifts up and it's going to work its way in, so it's connecting in that fashion. The other thing you can do as well is I like working with these leads here. We have this tangent lead, and depending on the surface that you're working with, it can kind of create a really good entry for the tool, and that's another great option that we have for using this radial to create a pattern, and you can tighten it up. If we're going to tighten it up, we'll tighten it up by our cut angle in this example. So if we make it a smaller cut angle and we recompute this, you're going to see that it gets a lot closer. The other thing we can do too is we can set, like, if we don't want it to go all the way to the center, we can go into our parameter here, or let's see, start radius. Yeah, we can set what a start radius is, and then that way it will stay away from the center of the part. Okay, so like we talked about as well, you can use your negative allowance to say how deep you want it to go. One of the things that a lot of the standard toolpaths have is this step down option too. So if you wanted to use this as a roughing routine, you would have the ability to rough this. Now, Steve has a question. Can you go into a little more detail about step over in 3D as opposed to 2D pocketing? Does the step over just always adjust to how tight the toolpath is? Steve, 2D pocketing and 3D pocketing step over concept is the same. You give it a step over amount, and then that's how far the tool will step over. What's different is how it's applied. In 2D, you have flat geometry, so the step over you get on one side of the part is going to be very close in most scenarios on the other side of the part. But in 3D, depending on the curvature of the surface, the step over is going to give you a different cusp height, because as the surfaces become more vertical, the step over distance doesn't necessarily accommodate for that. Again, that's going to depend on the toolpath that you're using. So that's just a quick answer on that, but hopefully that makes sense. So again, we have our step down value here. What this is going to let you do is to rough in that routine. So if it's a harder material and you want to take lighter cuts, you'd have the ability to step down with that. Okay? All right. So the last one that I want to show here for our standard toolpaths would be, well, let's go ahead and we'll run this simulation here real quick. The last one that I want to show is the plunge roughing, and this, using the plunge roughing, you're going to get a dimpled type effect, which I think is pretty cool. But you can see here, this is the routine here. Now, when it's stepping down, it does take a lot of passes in order to step down, because it kind of blends it from the top down. But you can see how it worked its way in there, And really without too much effort, just using a radial toolpath, we created a real cool pattern right on the top of this surface here. All right. So the next one we're going to want to go to is going to be the plunge roughing. So let's blank this guy out, turn the posting off, and then we'll load in another one. So we'll select all our geometry here. And this one we're going to do plunge roughing. Plunge roughing is usually used for roughing out your part, but we're going to use the same concept. It's basically going to drill a pattern of holes. We're going to put it on a 45-degree angle. We're going to set our step over. We're going to use our negative allowance, and we're going to compute our toolpath. Okay, and here you can see we have a bunch of points, and what it's going to do is it's just going to go in a row, and it's basically drilling on the top of that surface there. Okay, now in order to adjust the density of the dimples that would be created, you would use your step over amount. So I'm going to make this a little bit bigger here, and then we'll run this one through a simulation and see how this looks. This is probably one of my favorite ways to create a really cool texture on the top of a surface. As far as runtime goes, I mean, these types of strategies aren't the most the shortest cycle times in order to get some of these results here, but they do create really interesting looks and patterns, and again, the idea here is to you know, separate your designs, you know, do something to change either the look or the feel. And a lot of times what you're going to see is that these are used on things that you would touch or feel, maybe your feet or your hands or things like that. All right, let me go ahead and come in here and adjust this a little bit more so we can see the effect that we have here. There was another question that came in. Why would I on purpose use plunge to rough out material? Feeds go down. Marcus had a question about plunge roughing. Plunge roughing is a strategy or a technique for removing material. In harder materials, it comes up more often. I guess this was kind of more popular before the adaptive toolpaths have come out. Some of the machines don't have as high spindle speed range, and plunge roughing or drilling out material has just been a very common way in which it's been done. All the force is pushed down versus side force, so there's a number of different benefits for it. But it really does depend on the application. So hopefully that answers your question there. Plus, I mean, you can Google all kinds of documents on plunge roughing if you want to get more of a history and some of the benefits that are there. But again, usually you're using a larger tool. You just have downforce. You don't need the same RPM ranges that you do with the adaptive toolpaths. Let's see, Rich had a question. Firearm industry is using them a lot now. Yeah, firearms, you know, even sometimes just harder materials, and if you're profiling around. Hey, Rich, we'll catch you next time. No big deal, bud. All right, cool. So again, this is our dimpled effect here, and again, I think this is one of the cooler textures that we've come up with just the standard toolpaths. Okay, so those are some of the ways in which you can create textures on your parts using your standard toolpaths. What I'm going to do here is let me go ahead and turn this one off, and let's see. Okay, so we have that blanked out, or let me just blank them all out. Let me turn them all off. Okay, so the next question that we have here, let's see, one more before we go. Can the plunge rough be set up in more of a random order? James, we're going to talk about that a little bit later, but no, the plunge rough feature itself, as far as the dimple effect, would be based off your pattern. You have zig, zigzag, and you have an angle. So that is going to be the way that one works. But if you want a more irregular dimpled effect, there are some other strategies that we have with the BobART, which is our last topic we're going to get to today. Okay, so the next one that I'm going to talk about here is using project curves and 3-axis wireframe. Now, go ahead. Does anybody know where project curves is? It's a CAD feature. So if you know where project curves is, go ahead and raise your hand. Let's see. Okay, William does. So William knows that project curves is found under the other menu and project curves to surface. Okay, so what you use this for is in order to take wireframe geometry and project it down onto a surface. So that's the first part of the next category, which is project curves and 3-axis wireframe. So what am I going to do here? I'm going to create a pattern that I want to put on the top of this surface. The first thing I want to do is create a new layer, make it active. I'm going to go to Utilities, Extract Edges, Single. Okay, so I want to get the wireframe boundaries for this top surface here. I am going to use a Project to Z, Z0. I'll click on this surface, I'll hit my space bar, I'll hit cancel, and then I'll turn the first layer off. Okay, so what that does is gives me just this wireframe here. Okay, so the next thing I want to do from here is I want to create a pattern that I want to use. So I'll come in and do an offset, and we'll offset this in a little bit. Okay, I'm also going to put, let's say, a circle in the center. Okay. Okay, so we're going to do, we extracted the edges, we created an offset, we draw 2 circles on center. Okay, so the next thing that I want to do is I want to trim these away from each other. So what I'm going to do is I'm going to use our 2D Boolean for this. So I'm going to do 2D Boolean. I'm going to do a subtract, and I'll select shift-click this one, spacebar, shift-click this one and this one, spacebar, and it will cut those 2 away. All right, so that gives me kind of an area in which I want to work with. The next thing I'm going to do is maybe throw some fillets here. So I'm going to do fillet, chain, and I just want to round off the edges. So I'll just chain select these here, hit my spacebar, and now I've rounded off those edges. Okay, so that gives me the profile that I want to work with. Now, the next thing that I want to talk about is, I'm going to take this profile here and I'm going to end up projecting it down onto this surface. But the way that this pattern is right at this point, there isn't really a lot of texture to it. So what I'm going to use is something called crosshatch. You're going to find it under dimensions. So I'm going to use crosshatch. Crosshatch will give me a bunch of different patterns that I can choose from. I'm going to use this one here. I'm going to set what my spacing is. It's on a 45, and then I'll window everything in here and hit my space bar. And there you can see I have this crosshatch pattern, and this is what I want to project down onto that surface. Okay. All right. So that's the first part, is setting up my pattern. Now, the second thing that I need to do here is I need to use the project curves feature, which is under here, other project curves to surface, and I need to project these curves down onto this surface here. Okay. Now, there's a couple of ways to do this. One way to do this would be to, like, I'm going to just walk through it. So I'll create a new layer, make it active. I'll generally change the color that I'm working with just to have a contrast between the 2D geometry and the 3D geometry. Okay. I'm going to do other project curves to surface. I'll select the color blue, spacebar, and then I'll select on the model here. And what you're going to see is that toolpath was, that geometry was projected down onto that surface. Okay. Now the thing is, you'll also notice that it was projected down onto the bottom of the surface, because when I selected the model, it selected all the surfaces. So this is something you have to pay attention to when you're projecting geometry. In this case, this is one of the reasons why I put it on another layer. It's also a reason why I make it a different color. I'm just going to select the stuff off the bottom and we're good to go. So this gives me my pattern. You'll notice that this pattern it's curved along that surface. So here was the surface there. You can see it's curved along the surface. All right, so you can do this with text, you can do it with logos, any pattern that you create. And then now what we want to do is we want to take this pattern and we want to put it down on top of the surface here. So the way we do that is we use our 3-axis wireframe. Okay, so we'll go to 3-axis wireframe, select geometry, color, orange, okay, spacebar. Okay, so we selected the wireframe that we want to work with. The next thing that we're going to do here is go to our tool. We're going to go to our tool crib. In this case, I'm going to use a V tool. So I'll grab one out of my library here, and I'll say OK, and I'll say OK. All right, so we got our tool set up. Let's go ahead and look at our parameters. Now, you have a step distance, number of cuts, and then you have a cut to geometry or cut from geometry. So there's some different options here that you can use for the 3-axis wireframe. Cut from geometry is going to go from where it is, and then we're going to go down. So our step distance is going to be the same value that we're using, and we're saying make one cut. We'll go ahead and compute that, and here you can see our toolpath to our pattern here is now being machined across this surface. So let's go ahead and run this through a simulation. You can, there's a question that came in, can you project onto a 3D surface with V5? That's a SolidWorks question. I'm pretty sure you can, I'm not sure how you put a sketch onto a surface in 3D. I believe you can though. But I would have to check on that, okay? But you do have 3-axis wireframe in V6, so you can use that. It's just the SolidWorks' tool for projecting the sketch down. All right, so here we can see we have our V tool. It's going across the shape here. I think I may have got some double entities here because you can see it was taking multiple passes there. But again, using this pattern, we put this pattern into the part here using the workflow that we followed, and that you can use this again with all kinds of different patterns, okay? Do you have a JPEG logo example? Troy, I don't have a JPEG logo example. I would need, if I had a logo, I would vectorize it first, either by tracing it or vectorizing it with BobART, and then I would use that geometry. So, and this is very common to use logos for you. I'm sure you can go ahead and email me, Troy, if you have one, al@bobcad.com. All right, so that is the 3-axis wireframe using project curves as a CAD feature. It's a great way to go about some of this stuff here. Let me blank this guy out. Let me go to the top here. Let's see. I feel like I have double geometry here, and it may have just been the surface edge that I had worked on. I'm not sure, but you can see that it's in there. One of the ways that you could clean that up would be to, let's say, reorganize, erase doubles, select all. That will get rid of our double entities. So if I go to this side here, well, okay, no, it didn't get rid of it. And double entities, when you do clean up on double entities, the endpoints have to match up. So I feel like, I'm not sure exactly what I have going on there, but when I projected it, I got some additional geometry. So we would want to pay attention to that because we don't want to have to recut over where we've already cut. All right, so we may need to go and clean that up, but I want to keep going here because I'm running out of time and I got lots more topics to go through. The other thing that I wanted to show here, again, this is the cut from or cut to. We're going to do cut to. We're going to make 10 passes here. So I just wanted to be really clear, when you do cut to geometry, what we're going to see is that the toolpath will start above the part and then work its way down to wherever the geometry was located in 3-axis, okay? And then if we use the opposite, if we do cut from geometry and we recompute, what you're going to see is the toolpath will start from where it was projected and then cut down in Z. So that's really the difference between cut to and cut from, okay? The other option that I want to show here, let me remove my geometry. I'm going to create a new layer here. Let me get rid of that and that. Okay. Let's see here. Let me see which one it is. Okay, this one here. Okay, so here's a pattern that I created myself, just with some basic geometry. I'm going to go ahead and copy and paste it over into this drawing. We'll turn our solid back on. So a lot of times when you've created your patterns, you know, you want them to fit on the part, because one of the things that you'll see, let me translate this over first. Okay, so we'll get this on the part. One of the things that you're going to see when we do our projections here, so we'll do other project curves to surface. We'll select orange. Is going to go onto that. You'll see that it will kind of project it down these walls as well. You know, and when we're doing our 3-axis wireframe, the tool isn't compensated when we're doing that. So we really do have to pay attention to neighboring surfaces, because wherever the geometry is located, that's where the toolpath is going to be generated. Okay, so what we want to do is, let me undo that real quick. Let me use a different color. Let me create a different layer. I'll go through this process again. Okay, so let me turn everything else off here. I'm going to go from a front view. Let's see. Get rid of some of this stuff. So here you can see that it's rolling over the edges. Okay, so we're going to just select that geometry as well, and then we're going to compute that, and you're going to see in this example here, it's going to change the result that we're getting, because again, the toolpath itself is not, see how much further it's digging into this wall here. The toolpath itself is not being compensated for the cutter. So the user really has to pay attention to that, okay, when they're using project curves, because all they're doing is projecting the toolpath down onto the surface. So it's up to the user to pay attention to where that tool is going to be driven, or what surface you're going to project it down onto. Okay, so what are some of the things that you might do to prepare for that? Well, one of them would be to, when you're working with your image here, let's see here. Okay, so when we're working with our image here, we may want to scale it down. Okay, so we may want to scale it down, and but if we scale it universally, you run into some issues with it not really fitting where you want it to fit. So what we're going to do is non-uniform scale. Okay, we're going to select our geometry here, and then now we have a scale factor for X, Y, and Z. So in this example, in Y, I want to make it a little shallower, okay? So that way it doesn't quite go past over these edges here. And then in X, I also want to make it shallower as well. And you can work with these numbers. There is a preview that's being shown. So this way you can see, you can see what the result would be, and once you get it into a spot that works for you, you can see here I have the pattern now where I want it to be. Okay. Now another trick that you can do as far as when you're projecting down onto the surface, you can see I'm selecting the entire model. Another way I might do this would be to unstitch the model. Okay, so I'll go to Utilities, we'll go to Stitching, Unstitch Solid to Surface, and then what that does is it breaks it down so I can choose what surfaces I want to project to. So in this case, I'll pick these surfaces here. You know, we're going to just make these a different color. So we'll just make them a little bit darker. Okay, so those are the surfaces that I want to project onto. So now when we do other project curves to surfaces, we can select our orange color here. And then, you know, we can select, it doesn't let us pick by color here. Yeah, so we do have to, no, that did not work the way that I expected it to. Sorry about that, guys. It doesn't let you pick by color there. When I ran through it before, I just picked the top surface, so it worked in that example. Where if you unstitch it, you can pick a single surface and have it run just along to that. I'm not sure why it doesn't let you pick by a color, so I think development will get an email on that one. Okay, so there, if you were just working with the single surface, we can do project curves to surface. Let me change the color of this to a different color. Okay, again, we're going to select by color. We'll select orange, spacebar, and then we'll pick this top surface here. And what you're going to see then is that because we picked just that top surface, where it would normally generate a projection on some of these other shapes, like on the top and the bottom, it won't do that. So that's on a single surface, that's a trick in which you can do that. Could you stitch the top surfaces together? Yeah, I could. Yeah, that's actually a really good point. Let's give that a shot. Let's undo this. We'll go to Utilities, Stitching, Stitch Surface to Solid. Okay, pick by color. We'll pick this color here, spacebar, and then now that's made that one shape. It's a great example, Leonard, of thinking on your feet. Okay, so then again, we'll go back to here. We'll do other project curves to surface. We're going to pick the color orange, spacebar, and then now we can pick these top surfaces there as well. So great point there. We can stitch those surfaces together. I still feel like you should be able to select surfaces that aren't stitched together, but there may be some reasoning behind there. So thank you. Good catch. All right. So again, we've used our pattern. We scaled it to the size that we need it to be. Now we're going to reselect our geometry here. And again, the point of this one is where you can use scaling to get your pattern to cut where you want it to cut. And again, the toolpath is not being compensated for your cutter, so you really need to pay attention to that. All right, so we talked about extract edges, the offset of arcs, 2D Boolean, crosshatch, chain fillet, project onto a surface, using different colors when you're doing projecting, 3-axis engraving or 3-axis wireframe. Cut to versus cut from, and the non-uniform scaling. Okay, so now we're on to the next one. Okay, the next one is going to be the mill professional project curves. What about cutting the stock around the pattern? Can you trace in BobCAD to vectorize? If you have BobART, you can trace images and you can vectorize them. And then as far as Troy is the boundary you could create offsets and project that down to kind of do like a pocketing routine or something like that with your projected geometry. So that's how you would do raised or lower in that type of scenario. Okay, so let me turn this one off. Let's move on to the next one. Okay, so when we look at these other, where do I got my solid? Let me move this over to, we'll move it up there. Okay, so now what we're going to do is we're going to use the project curves toolpath. Now this one is really, there's a lot of different ways that you can use this. It's probably one of my favorite 3-axis toolpaths. It's called project curves. You do need the mill professional in order to have this toolpath. Okay, we're going to use a ball mill here. We're going to need to pick some geometry that we want to work with. Same concept here. We're going to use negative allowance. All right, so let's finish that. Let's select our model. Okay, and then now what we need is we need some curves to project. So I'm just going to create like a spline here, which is fine. Okay. The light color is probably killing you guys, so let's darken it up. Okay, so we have our model, we have a curve, and we're going to project this curve down onto that surface. So we're going to select projection curves, spacebar, we'll recompute, and then what this is going to do is it's going to lay that toolpath down onto the curve. So where if you're a mill standard user, you have to project the geometry down onto the surface, and then you use 3-axis wireframe in order to convert it to Toolpath. If you're a Mill Pro user, you can use project curves, and it kind of combines the two of them. But that's not really where the value is. Where the value is the fact that it offsets for the cutter. So unlike when we projected the last pattern down, you saw that it was right on the wall of the part. This one has been offset for the ball. So it's actually compensating for the tool. And that's actually a very useful feature in a lot of different reasons, okay? So one of the major differences between project curves and projecting geometry and using 3-axis wireframe is the ability for the software to compensate for the cutter. All right, so now when we look at this a little bit here, there's some more that we may want to do. Like I'm going to come in here, and some of the options we've talked about before, pick bottom, maybe I don't want it to go any further than that edge of the part, so we're able to do that. The other thing we may do is add like a lead in, so we can go leads. We can do vertical tangent, recompute, so you add your lead in and lead out. That in itself is pretty cool, but then the other thing you can do here is you can come in, instead of using a user-defined pattern, what you can do is an offset. You can tell it whether you want an offset to the left, offset to the right, or go in both directions. So I'm going to say 10 cuts and 10 cuts in both directions. I'll go to my parameter to say what the step over amount is. I recompute this, and then what you're going to see is that pattern is now being applied across the top of that surface. So giving you the flexibility of using your own input geometry, but then also having an offset pattern built right into it, which I think is a really, really useful feature. And again, if you're a Mill Pro user, there's a lot of different ways you can use project curves, not really just for patterns or texturing of your parts, but this is just a really quick way to show you how this works. And again, you can create all kinds of really cool patterns along your parts. Now, one of the things that I want you to notice is, as a Mill Pro user, some of these strategies you have some linking control. Like here you can see this is linking back across the part, and it's running along that surface. And we may choose that we want it to go to clearance instead. Here's another link move right here. You can see how it's linking across the part. Well, you have the option to edit that under the, let's see where it is, links tab. There's a filter, max link gap. Right now it's set to 200% of the tool diameter. We can make it 10% of the tool diameter, and that will force the tool to go to clearance the length versus coming across the surface. Okay, so that kind of a useful tool if you see with your 3-axis Pro Toolpaths where the tool is linking across the surface, you can use your link parameter there in order to adjust whether it goes to clearance or whether it cuts along the curve. Rob says his screen is frozen up on his end. Everybody, if you raise your hand if my screen's still moving for you. Looks like it is. So Rob, it must be something with your internet on that end. Sorry about that. Okay. All right. So that's a little bit about project curves. The last one that I want to talk about here has to do with BobART. Okay. So with the BobART, you, instead of applying the toolpath to the part in order to get the texture, we're actually going to apply the texture to the model. Okay, so let's go ahead and blank this one out. Now, in order to do this, you do need the BobART software. That is something that you need. One of the things that we're going to do is we're going to look at our embossing options. So you have emboss from solid surface, you have emboss texture, and then you also have emboss from image. And these are some of the tools that you would use in order to put textures on the surface of your model. So let's take a look at this. We're going to do, we're going to create some stock. I'm just going to make it a larger area here. So -5, -5, 10 by 10. Okay, we're going to say okay. So that gives us like the BobART surface, which is kind of like a sheet of paper. And then we start embossing, editing that sheet of paper. It's kind of like we emboss to it and the paper lays over the shape that we're working with. Okay, so the first thing we want to do, we have a BobART surface here, or stock. We want to emboss our solid here. So we're going to do emboss from surface solid. We're going to say add. We're going to say okay. All right, we select our model. So we'll say select all. We select our model. Now, if we emboss it, or if we regenerate our embossment right now, you're going to see it shifted out in space, okay, because the BobART surface will emboss based off of 0. So one of the things you need to do after you've selected is use surface position. So you click that, then it knows where the surface position is. We say okay, we regenerate, and then now you can see that it's embossed right to where that is. Okay, now there is an accuracy of the embossment, so you can turn down the accuracy when you're laying things out, and then as you get it closer to where you need it to be, you can turn it up. Okay, so what we're going to do here, we're going to leave the accuracy the way that it is, but what we want to do is apply a texture to it based off of an image. Okay, so we're going to come into our emboss model. We're going to go emboss from image. From here, I have some images that I can use. Now, I used the spiral in the image that we saw for the webinar. Okay, so again, you can see that it's being applied to the surface, but it's kind of in this quadrant over here. What we would do from there is kind of adjust, adjust maybe where it is. This is one of the ways to do this, is to adjust where that is, and then we can recompute, and then we can kind of bring it into position to apply it across that model. Okay. Now, another way we can do this, instead of using emboss from image, we can do emboss texture from image. Okay. This is going to give us some additional options. We'll use the same image as we used before. The difference is we can come in here and we can scale the image to the stock size, okay? And then we can regenerate that, and then this will put the image across the entire stock. Now, the other thing you can do too is you can use a boundary, and then you can limit it back to the boundary. With this particular technique, what you're doing is you're taking an image, which is going to be your pattern, and then you're applying it to that surface, and then you're using your 3D toolpaths in order to create the texture on that surface. Okay. Now there's a bunch of samples that I got, and I seem no matter, every time I get into these, it seems like I never have enough time. You'd think in an hour you could cover a whole lot. So I don't know if I'm going really slow or if I'm just picking too much information at one time. I know we're right at the 2 o'clock mark. So there's a couple of more examples that I wanted to get into if you're going to stick around. If not, I completely understand. I want to do a little housekeeping before anybody jumps off just yet. Let me see here. Let's see if you guys don't mind. We'll run this poll here real quick. How long have you been using BobCAD for? If you're a new user, let me know if you just got started, if you've been using BobCAD for a long time, just so we have a good idea of the user base that are coming in here. It seems like a lot of you, if you have been a regular, if you're a reg or a regular and you're coming every week, go ahead and write that in the comments as well, just regular, I come regular, just so I know. Most of the names I'm starting to recognize, but if you're a regular, just go ahead and type that in there. I'm going to go ahead and close down this poll. Thank you so much for everybody voting here. It looks like most of you here are done voting, so we'll close that one down. The next thing that I want to talk about real quick is what kind of training works best for you. Do you guys like video training? Do you like online training or a screen share? Do you like training seminars, or do you like books and tutorials? Okay, just so we have an idea of what you guys are mainly interested in. Everybody enjoying today's webinar? Hopefully so. Keep this open just a little bit longer here. Mark says he is. Cool. Leonard, Brad, Bill, Ken. Seems like you guys are liking it. Going to go ahead and close this down, and that looks good. Let me do one more for Nick, because he likes all this kind of information. Okay. When you're evaluating new software, what is most important to you? Demo test drive, one-on-one demo, online reviews, or your good old buddy giving you a recommendation? Hey, I got this stuff and it's awesome. I don't know what works best for you. I do a little bit of online reviews, but I definitely listen to the recommendation of people that I respect. For sure. There's some questions about whether this video will be available later. This video will be available later. Generally, if you've signed up for the webinar, you'll get an email with a link to the recording of the video so you can watch it later. And then I've also been doing a more condensed version. So instead of taking up an hour, I do like a 15-minute version, which kind of is the highlight reel of what we've talked about. All right, let's close this down. Okay, so that's enough with the housekeeping. Now, all right, Kevin, we'll see you next time. Cade, hey, nice to see you, Cade. All right, bud, if you got to go, no big deal. We'll see you soon. Okay, what do I want to do here? Let me, I want to kind of give a practical example here. I know I've gone through a bunch of information. I want to go through kind of like a practical example. So I did this this knife blade here. Duncan, we'll see you next time. I did this Duncan here, and I'm sorry, I did this knife blade here, and this is kind of where I see a lot of this stuff coming in really handy, is when you're doing like handles for things that you're holding on to, okay? So when we look at this particular part here, what I'm going to do is I'm just going to isolate this top handle here, put it on its own layer. So there we can see the parts on its own layer. Okay, so for this one, we could use either project curves, we could use either creating wireframe and putting it on. Yeah, you have a lot of different options. I'm going to go through the 3-axis wireframe version. Okay, same thing that we had covered before. We're going to do that in this example here. So I'll create a new layer, make it active. I'm going to change the color that I'm drawing in. Utilities, extract edges, single. Okay. Project to Z0, pick on the top surface, spacebar, cancel. What that's done is given me the profile to work with. Now, from here, what I'm going to do is I'm going to offset this profile. Give me a border. Okay, so we'll go to the inside. We'll say okay. All right. Now, depending, you know, I mean, I could do all kinds of different patterns and things, but what I'm going to do is let me trim this out here, okay, is I'm just going to do a crosshatch. So I'm going to do dimension, crosshatch, set what my spacing is, select my boundary. All right, so now I have my crosshatch, okay? So the next thing that I'm going to do here is this one. I got to get my job set up. So I'm going to do new job, milling job. This is going to be based off the solid model stock. I'm going to pick the solid here as my stock. Next, my 0 is fine. Okay. So I got my job set up. I got my 0 set up. I have my geometry that I still need to project. So I'm going to create a new layer. Let's go to this light blue color here. So we're going to do, let me get rid of the outside profile. We're going to do other, project curves to surface. We're going to select the color blue. Then we're going to put it on the color orange, and you can see that that's projected it down. It's done it. on both the top and bottom surfaces. So we'll go to a front view. We'll select away the things that we don't want, and this gives us our pattern, okay? So again, that pattern we want driven along this surface here. From here, we're going to go 3-axis wireframe, select geometry. We're going to select the color blue, spacebar, next. Again, we'll pick our tool. So this is going to be a V tool. Pick an appropriate one. Say OK. We're going to set our depth, how deep we want it to go, and compute. And just like that, we've taken, like a knife handle, and we're able to do a pattern on the grip. And again, using the different geometry layout tools that you have, or your own creation, you can create some really cool patterns. But don't underestimate using like radial and spiral in these examples as well. You can get some really good results. Now, Leonard had a question. I don't have the color box next to my all tabs button. I've added this here because what I used to do is do pick by color and then pick by color. So it was an extra click. So by putting this one here, now I can just click it and then click on the color that I want. So something recently I added to my interface. If you haven't seen the Getting Started CAD, Leonard, it covers how to update the interface and how to change things, okay? So I definitely would recommend you do that. If you just search Getting Started CAD for BobCAD, you'll see that video come up. You'll learn how to change those toolbars. So again, just a really simple example. This one's a knife handle. Using the project curves, projecting geometry down in the 3-axis wireframe, we were able to put a pattern in the handle. Now I also did some 1911, like a Colt 1911, I believe that's right. Hand grips here, same concept. This one I used a pattern that I offset myself on it. And we're going to machine that pattern into the surface here. So things that your hands are going to touch, you're going to find that these toolpaths do a really good job for this kind of stuff, all right? Now, the other one that I did here, what do I have? What's this one? This is more like a brake pad. It really could be anything. These are just different examples of ways that you can use the strategies that we've talked about today. A couple of files that I had prepped. So you can kind of see, it's not always about putting, something cool. It could be, just a pattern that you want to put onto a 3D surface. So that's a way that you could do that. Let's see what the last one is here. This one's just more, this is a cone. This is kind of going through some of the radial examples. Like this one, I did this radial pattern here, which, again, for round shapes, it really makes sense. And then, all right, Mike, we'll see you next time, bud. Then the next thing I did is I used the project curves, or actually this one showing the project curves 3D toolpath, where, I was able to create kind of like a zig pattern in there, which you wouldn't get with the traditional radial type toolpath, because it would just start from the center and work its way out, or go from the inside, or go from the outside and work its way in. So using the project toolpath, I was able to use some custom geometry to create a different effect, okay? So I really appreciate everybody spending some time with, with me here today. I enjoy your company and all your questions. If there's any last questions that you guys have, why don't you go ahead and throw them out there. I know Troy's had a bunch of questions about working with logos and converting things. So yes, you would use BobART to vectorize and image trace. Troy, a lot of the 3D patterns for logos is done with grayscale. So, if you want to learn more about that, I recommend a one-on-one demo for BobART. That way we can cover it. Thank you, Leonard. I look forward to seeing you in the next one. Do you have to have BobART? No. Most of what I've shown you here today, Brad, you could do with Mill Standard. or Mill Pro. BobART just gives you vectorization. Yes, you have to have BobART to vectorize. Yes, you have to have BobART in order to emboss based off of an image. Thank you so much for sharing some time with me here today, Ken. I appreciate you showing up. I don't know when I'll do a webinar on BobART next. Next webinar up is Intro to Turning for CNC lathes, but we'll definitely get something in there on BobART. Can you show BobART vectored image onto your model? Yes, I don't have a file right in front of me right at this moment, but yes, you can vectorize an image or use an image on the model. Let's see here. Hey, Mark, no problem. Thanks for spending some time with us today. Yeah, you could do your logo stuff, Brad, in the BobCAD, the standalone. Thank you, Johnny. I appreciate you spending some time here today. Hope to see you next time. Yes, Steve, it's okay. Usually I try to start right around 1:05. I wait for some people, but next time. But you will get an email of this recording. Yes, I'm going to do, Blake, I'm definitely going to be doing multi-axis and pro webinars. I just worked on an impeller, so I'll probably go through that coming up here at some point. So just check your emails. We email you guys about this stuff if you signed up, so you'll see an email coming. All right, Chris, we'll see you next time. Rob's got a question about lathe turning and a mill with cutter help in the vise spindle end. Not sure exactly what you're asking there, Rob, but I'll see if I can respond to you via email. I may get into a little bit of mill turn, but intro to turning, I really got to keep the subjects back so I don't spend too much time on one thing. Yes, there is BobART V6 that does do vectorization, and you can do patterns and things like that, Brian, so that's there for you. Not sure. I'm not sure what's going on with your chip load there. We'll have to take a deeper look, but that's all I got for you guys here today. Again, I appreciate everybody's time. Look forward to seeing you in the next one, and we'll go from there. Thank you so much, guys.